traditional poll to start any kind of meetup presentation. Who here is primarily a Java developer? Kind of day job or hobbyist? Okay, cool. I think you're our main audience here. I know this is a JVM group, but we kind of assumed in the things we're putting together that most people here will be cutting Java code most of the time. So thank you very much, MelbJVM, for asking us along. We have great pleasure in talking to you about a language which is close to our heart. Now, many of you might be familiar with the term, there's nothing worse than a reformed smoker, okay? Because the reformed smokers are kind of the most evangelical, smoking is evil, evil will kill you, go to hell, etc., etc., etc. I'd like to extend that a little bit with something along the lines of, there's probably also nothing worse than a reformed Java developer. Because both Olga and I stand here having had the opportunity to, having done a lot of Java development in our careers, work with Clojure for a considerable period of time at a local client, IOOF, a couple of years ago. And it has, I won't say it's transformed us. We haven't had an Alleluia moment or a kind of come to Jesus type thing, but it certainly has changed the way we think about development, and it certainly very much changed the way that we think about Java. And that's what we want to talk to you about tonight. That said, this is not a Java haters talk by any stretch of the imagination. It's very easy, if we chose to kind of put up straw man side-by-side examples of this is Fibonacci in Java, this is Fibonacci in Clojure, and kind of like shock and awe you with how little code it takes Clojure to do that sort of thing. But they are like very, very toy examples, and it doesn't have much bearing on the real world. So I'm going to try and paint as balanced a picture as I possibly can, or as we possibly can, around the benefits of Clojure and in general functional programming. So what are we going to talk about? Okay, we're going to do a quick intro to Clojure, and then we're going to back off a little bit and talk about functional programming languages in general, because that's really the more important thing than any particular language. We're going to look at the basic syntax of Clojure, which is actually very, very simple. We're going to, or rather Olga's going to talk about web app development, which is probably something which is a bit more real-worldy, a bit more of a faithful representation of the sort of stuff that people sitting in the audience might be doing on a day-to-day basis. Then we're going to finish up with some limitations from our point of view, having come from a predominantly Java development world, coming into Clojure, and also a few resources in case we've kind of piqued your interest with any of the things that we've said, some takeaways for you, some URLs you might want to go and have a look at. So that's a general structure of what we're going to do. This is my main premise, I think, for this talk, and you will have seen this quote before. I actually didn't realise this is from Abraham Maslow, who's famous for lots of other things, but I knew the quote. And the analogy here is, if you only have one particular way that you can look at a particular problem and formulate a solution for that problem, then every solution you have is going to be constrained by that way of doing those things. If you only have a hammer, then every single job you have to do is going to look like a nail, and you're going to try and get that screw or nail or thumbtack or a piece of wood into where it needs to go using your hammer-like approach. And again, kind of digging into this a bit more from a Clojure point of view, our hypothesis is if you only have one particular way of programming, one particular paradigm you're comfortable with, be it an imperative OO sort of world, which is where most Java developers will be, then all the solutions you're going to be thinking of are going to be conceptualized through that lens, through that notion of what classes and objects is going to form this solution, how are they going to collaborate at runtime. And that might indeed give you the best solution for the problems you're dealing with, but having another lens to be able to look at those things through, and functional programming does give you another one of those lenses, is a very, very useful thing to have. If you're not familiar with that quote, you may have read that book. Okay, Pragmatic Programmer. If you haven't read it, I'd strongly advise you to do so. It's agnostic of any particular language, but it does have pearl after pearl of wisdom about just general good developer practice. And this is one of those. Learn at least one new language every year. We could care less, to be perfectly honest, about whether you choose to learn Clojure. But if you are the sort of person who kind of takes that to heart, then maybe some of the things that we say tonight might give you a bit of direction as to what that language for 2016 might be, if indeed you haven't chosen one of those already. Okay, intro to Clojure. This is like a cobbled together introduction from bits and pieces of the main Wikipedia page about Clojure. It's a Lisp dialect. I first learnt a variation of Lisp called Scheme back in university days. Hated it with an absolute passion. Too many bloody brackets everywhere. It was a competition between that and Smalltalk and Eiffel, and Smalltalk and Eiffel won hands down at that particular time. It took me a good 15 years for me to mature quite a lot to be able to come back and understand the elegance of that way of writing code. But Lisps have been around since the dawn of time. I think the 50s was the first time Lisp type languages came out. That emphasis is mine, so the bold bits are mine. They're the things I'm kind of curious about from a Clojure point of view. It's dynamically typed as opposed to Java, which is statically typed. It does rely by default very heavily on runtime reflection to be able to convert that dynamically typed world into a statically typed Java execution environment. It does treat code as data. Now, if you're the sort of person who likes to impress people at fancy cocktail parties with impressive sounding names, homoiconicity I have for you, which is the term used to describe languages which treat code in exactly the same way as data. And if that concept isn't quite clear to you just yet, when Olga talks a bit more about some of the configuration for the web app development, maybe it'll come a bit more into a clear picture. And it encourages immutability. In fact, it's immutable by default. And I know immutability is a good thing because I read it in the book called Effective Java, written by Josh Block way back in 2002, 2003, whenever that came out. Another amazing book. I thought I knew Java really well until I read that book. And when he was talking about don't put setters on your objects, do everything through constructor initialization, take deep copies of things which have references to them that could get mutated elsewhere. So this has long been an established way of writing code which is much easier to reason about and much easier to work with when you live in a kind of multi-core environment, like most of the software we write these days. Okay. Runs in the JVM, obviously, while we're here. CLR if you're a Microsoft person, and JavaScript as well, through a slight variation of the language called ClojureScript. Okay, enough of the Clojure specifics. Let's step back and talk about functional languages in general. And I have remembered to take my mic off. That's good. Hopefully I'll make the same transition the other times.
I might forget. I'm very nervous. So.
Come on, come on. Here we go.
Thank you.
You probably need that bit too, or it's going to be embarrassing.
There are going to be a lot of those during the talk. So one would ask yourselves, why would you bother learning the completely new paradigm, the completely new concept? We already have the stuff, functional stuff, in our favorite languages like Lambdas in Java, Clojures in Groovy, and why would I bother just going ahead and learning the completely new, different way of developing applications? Well, what I asked myself when I looked at Clojure and thought of doing functional is, why would you introduce in our good old object-oriented programming languages new functional ways to solve problems? I went to Oracle, like a nerd I am, and I checked why lambdas are in Java 8. And according to Oracle, lambdas have been introduced to Java 8 to simplify single method implementations of the interfaces, to simplify concurrency, and to make the collections manipulations way easier. So what my take on it is practical reasons. It's just easier. It's easy to read. It's easier to parallelize. Just easier. So functional, in fact, has been adopted in some of the big companies already for easy, usability, easeability, scalability, whatever ability you choose. And here are some examples. For instance, Scala is used quite a bit at Twitter. And I'm quoting here because it's scalable, fast, and easy to read. Erlang has been used in some of the back-end services in Facebook, and Clojure in Netflix or Puppet Labs. Closer to home, I know REA is extensively using Scala for their applications, and as Andy mentioned, we both worked at IOOF on Clojure projects. So what does functional bring to the table? What benefits does it have? Well, to begin with is, as Andy mentioned, there are no side effects. There are no mutable objects. There is no reference to the global state. Why do I bother? Well, one of the main bugs that have been risen in object-oriented programming is from the mutable state. It's because we update the object or the value somewhere else and we forget that we updated and we refer to it and it's like, oh, mess. You can trace it, but still. So in functional, because there is no mutable state, that's kind of solved by default. Note though here, you sometimes do need to use state. Like for example, especially if you're dealing with I/O. Functional programming languages by no means say state is bad. It just says use your superpowers for good. Use mutability only when it's necessary. Languages are declarative. They focus on what you're trying to achieve rather than how you're trying to achieve. reduces the whole bunch of boilerplate code and makes it slightly misaligned with your good old object-oriented programming languages, because you used to writing the for loops, the if statements, the whole idea, the whole algorithms to achieve things. Well, in functional, you're just trying to like map, filter. You try to focus on what you're trying to achieve. It lets compiler to figure out how to get there. So all of the boilerplate code is still happening in the background. You just don't see it. You don't write it. Also, functional programming languages that's kind of related are referentially transparent. What is referentially transparent? Is whenever you can replace an expression with its value without any effect to the final result of the program flow. So replace the function call with the value that it should be computing, and the program works. Because there is no state, you can do this fairly easily, because the whole idea of a function is to deliver one value and one value only. It's computed always the same way. There is only one path from point A to point B. And which makes it more trackable mathematically, but that's going to the math world, who wants that. For me personally, it makes it very idiomatic. It makes it easier to read. It makes it easier to trace. I don't need to go into some crazy library code. I know exactly where it comes from, exactly where it goes to. That's me personally. Because there is no state, they're concurrency friendly. In our good old object-oriented programming languages, objects have been designed for one reason and one reason only: to maintain the state. You update the state via the function, the methods on it, not functions, sorry, and you get the state of the current state of an object at a point of time. Well, in this particular scenario, concurrency becomes kind of difficult, because you need to make sure that synchronization of the data is happening properly, and it just gets messy. Because in functional you don't get the state, you don't have the constant updates to the same object, the concurrency and parallelism becomes easier, way easier, seamless, because you always, again, as I mentioned, get from point A to point B in the same path with the same values at each point of time. And last but not least, maybe it's not necessary for your particular company, but we at Thoughtworks value it. Functional is industry positioning. Functional is kind of hip at the moment, let's admit that. It's everywhere, and hip stuff and using hip technology attracts talent, in particularly development talent. Everybody wants to have more development talent in their company, so do functional to be more cool. So that's about it for me for the spiel on functional, and I'm going to pass on to Andy to talk about basic syntax.
If nothing else, I think through Fendi and John talking about Groovy last year, and the two of us pairing here, we're going to force MelbJVM to buy another mic. Okay, so we've kind of held you off long enough in terms of the actual syntax of Clojure. Again, another kind of typical quote. Who's used a Lisp before of some variation? Clojure, scheme, common Lisp, any of that sort of stuff. Okay, you people can go to sleep for the next 10 minutes or so. So I'm going to go with tradition and start with the normal way that you introduce any new syntax to an audience, which is this is how you do hello world. Clojure has strings, that's how you do a string in Clojure. If you are using the Clojure REPL, interactive shell sort of thing, then you can type that in and you'll get that string back again. Okay. But that's not all that useful in and of itself, so let's wrap that into a function. And that's how you do that. So there's a bunch of extra bits I popped up there. I'm going to talk through each of those in turn. So the first bit, that first line is a function name. Okay, technically it's actually a macro name, but for the sake of this conversation, macros and functions are equivalent. So that's a function name. Defn, defined function, this is a contraction of those two terms. Whenever you have a function call, a function that you're going to evaluate in Clojure, it is always going to be the first thing after the left parenthesis. Okay. The second parameter there is a symbol, okay, and in the context of this thing, that symbol is going to become the name of the function we are creating. So hello world. Parameter list to that. Clojure has a bunch of built-in collection types, sets, maps, lists. This is a vector, square brackets means vector. This is an empty parameter list. Okay, so no parameters being passed to this function. And then finally, we've got the function body itself, which is just the string we have. So that's how you define a function in Clojure. Okay. Now, how do you evaluate it? You just use the symbol of the function name, wrap that in brackets again, and then what's returned from that function, which is that string hello world, will be what's returned when you evaluate that function. So how would you actually do that if you were writing Clojure? You would probably pop it in an application, okay, which requires a little bit more code to turn into something that you could run from the command line. And again, there's some new code here that we need to talk about. That function call up there, the NS stands for namespace. For the sake of this conversation, think of a namespace as being like a package statement from what you'll be used to from a Java point of view. It gives you some sense of modularity around the code that you're building beyond just the natural module that you get from a single source file. Scratch the under the hood a little bit and they are very, very different concepts, but conceptually at this point you can treat them as being the same. And there's that same correlation between kind of directory structure and file name in Java packages that you get with namespaces in Clojure as well. We've got a compilation directive, okay, to tell the Clojure compiler that when it's building this, create a class out of this, and I'll show you how that works in a little bit. We then have another function that we're creating. This one's a static function because we have that hyphen just to the left of the symbol there. And you're probably well ahead of me here. This main to a Clojure application is semantically equivalent to the public static void main that you're used to with Java standalone apps. We've got a doc string, so this is the way that you define documentation for a particular function, how you tell the Clojure environment what that does, and there are functions you can use to access those doc strings quite easily as well. We've got another parameter list here. This is variadic, which means it's like multiple arguments. They're all going to get bundled together into that args collection. And then finally, we've got the body of the function, which does nothing more than execute our hello world function and then print out what's returned from that to the console. So when we run that, and that's how we probably would run that in a Clojure world from the command line, you'll see that string coming out. Line is short for Lineagen. Lineagen is to Clojure what Maven or Ant plus Ivy are to a Java world. However, Lineagen's really the only contender, or it's certainly by far and away the most popular contender in that build automation, build management tool space in Clojure world. And when it runs an application, it's going to look at another file that I haven't shown you, and it's going to execute that main function, which is going to do all the stuff that we saw in the previous slide. Under the hood, that Clojure source is going to get loaded by the Clojure environment. It's going to get turned into Java bytecode because it runs on the JVM, same as if you're running Java source. Then that's going to get streamed into the JVM to be executed. Okay. Of doing it as well though, because the way we showed you just then will only run within the context of Lineagen, because that source code that I showed you had a couple of references to things from the Clojure core library. The namespace definition at the top of the file, the defn function, macro, and also that print line function all come from the Clojure core library. And we need to bundle those in with our Clojure source if we want this to be a standalone application that we can run just like any other Java application. And Lineagen has a way of doing that. It's what's called building an uber jar, or a jar with all the stuff in it. So if we say line uber jar, and it will create that hello world jar, if you would unpack that hello world jar, you would find the class files generated from our source file, and it will actually probably be a one-to-many relationship, and you'll find about an extra 2,000 class files as well. And those 2,000 class files represent all the code in the core Clojure libraries. But pack them all together into a jar, and you can run it just like a Java program, and it will give exactly the same result. And again, all we've done is introduce a very explicit compilation step. In the previous version, the generation of the bytecode was happening in memory, in process. This time it's actually generating class files on disk, which then are being bundled into that jar file and then loaded as any other Java jar file would. If you're more interested about the way that Clojure creates bytecode, the bytecode it actually generates, there's a reasonably good reference down there that goes into quite a lot of detail. Okay. To understand Clojure syntax, you need to understand this notion of S expressions. S expression stands for symbolic expression, and it's the core of all Lisp-based languages, and it's the thing which is responsible for all the bloody brackets, okay, if the brackets are the thing which annoy you about this type of language. It is a very simple mathematical notation that allows you to define lists and nested lists. And there's only a couple of real rules. In between the parentheses, you can either have an atomic expression, so something which not quite evaluates to itself, but has no lower level of meaning. Or you can have, and that's an example of one of those. And that's another example. We saw that line from a couple of slides back. Or you can have a more complex S expression, which has a combination of those atomic elements and also a nested, further nested S expressions. So this is another function definition. It squares a parameter that's passed into it. It does that by calling the multiplication function. And because there's those nested brackets there, that's an S expression within another S expression. Syntactically, that's about it when it comes to Clojure. Okay? Everything you see, as always, whenever you hear someone say an absolute, like everything or never, they're always wrong. There's always exceptions to that rule. But with that in mind, everything you see in Clojure source is going to take that format, that's S expression format.
Is that, I noticed that the Polish, or it looks like a Polish type notation in the mass.
It is prefix notation, yes. Yes, yep. So the function name comes first and then the parameters after that. Okay. There's another one that's more nested again. You'll see this line if you look carefully at the test expressions that Olga's going to show you when we're talking about web apps. But that's calling an all function, which is part of a namespace that we're calling subject. It's getting the return result of that function call. It's passing it to a count function, which counts how many elements are in the list. It takes the return of that expression, passes it to an equals function call, which is comparing the size of that collection or size of that list to 1, which is therefore going to return true or false, which then passes it to the Clojure unit test framework function called is. If that is true, that will continue the execution of the test. If that's false, it'll throw an assertion error, the way that you would normally expect with an assert equals or an assert in JUnit or something like that, test ng. Okay. But again, it's still S expressions all the way down. They only hold atoms or they hold nested S expressions. Okay, let's talk about idiom. Because syntax, when you're learning a new language, is actually quite straightforward. For any new language that you learn, it doesn't take you very long to actually learn the syntax. The things which take a long time is to understand what's available to you in the core libraries or the common libraries you're using, and this applies to any language. And then, how do I write code in this new language the same way that expert developers write code in that language? How do I do it in an idiomatic fashion? Here's some Java code which I think will probably compile. I don't write any Java these days, but that looks kind of okay to me. If I was to write a function to a method to calculate the length of the hypotenuse of a triangle, that's probably how I do it. That's the equivalent code in Clojure. Okay? And the key point here, I think, is to note that I haven't used any of those local variables. I haven't created local variables to store those intermediate results from the side length calculations. I've actually inlined those calls here and here as part of that plus function call. And that inlining, that kind of compression of those function calls is very much a part of idiomatic Clojure. And it's what generates a lot of those end of function lists where you're popping up or popping out of lots of those nested function calls. Okay. I could have, if I'd chosen to, written that function that way in Clojure. Okay? And that's the way I probably would have done it for the first 3 months that I was writing Clojure. I wrote code which is very similar to the way that I wrote Java code, which was kind of lots of temporary variables using that let function to be able to do that. But over time you do progress just by looking at more code that's been written by expert developers to a more idiomatic fashion. Okay, enough about idiom. Let's talk about interop, because Clojure does run on the JVM. It talks to JVM very, very easily. It talks to Java very, very easily. The interop the other way is a little bit more complex, but not so much so. So the yellow bits are just like the syntactic intricacies of how you talk from Clojure down into kind of Java libraries, Java classes. And you can probably work out from those examples there what the Java equivalent of each of those statements are. And there's a URL there for you to have a look at if you want to know more. But it is very, very straightforward to actually access all the Java code that you might be used to, either from standard Java libraries or anything else you have on your class path. Going the other way, it's a little bit more complex, but not so much. Got to import a couple of packages to get access to a couple of functions you need. But what I'm doing in these 3 lines of Java here is the equivalent of that 1 line of Clojure code there. I'm calling a function called map, okay, which is a standard kind of functional list comprehension map type function that you see in lots of languages these days. I'm passing it 2 arguments, one of which is a reference to another function called increment, and also a vector of values. Okay. So map inc123, which is the Clojure version, is going to return a new vector with the values 2, 3, 4 in it, because it's incrementing each of those values. And that's how you do that in Java. You get a reference to the map function, a reference to the inc function, and then you invoke that map function, passing it the parameters that it needs. Okay. So it's fairly straightforward as well. Okay. And again, a link there for people who want to know more about Java interop. All right, enough of that kind of low-level syntax and interop stuff. Let's have a look at some more really worldy type apps, and I'll get Olga to talk to you about web application development.
Oh, thank you.
That.
Yep, thanks. So, Andy and I, most of our day job, we happen to work with lots of REST services, and particularly at IOOF, we were developing REST services in Clojure. You can do the front end as well, but let's show you just the back end at the moment. So essentially, what would it look like if you have a Clojure application that does things for you? To begin with, as Andy mentioned, one of the main building tool, the most popular building tool that exists in Clojure language is Leiningen. Leiningen, in this particular case, I created a project that is configured for Leiningen, and it is a Composure project. Composure is a library, web app library, REST library that's similar to very lightweight drop wizard that's running on Ring service, which is a wrapper around HTTP, Java HTTP connector, I believe. If I'm wrong, please correct me. So the main part about each of the Clojure project is project.clj file. That's where your configuration's happening. Now, the first time I looked at it, it's like, what the? And then I started reading it, and essentially it's just like a function call. Well, actually it's a macro, but for the intensive purposes, it's like a function call where you provide key value pairs to configure your project. So it treats your configuration as freaking data. So in this particular case, you provide your description, your application name, your description, your URL, your dependencies. Now your dependencies are similar to Maven. You can provide classifiers, exclusions, global exclusions for the entire project. So you can check out how the sample per project.clojure file look like. You can provide your plugins for the Leiningen to run the application, profiles, which are development, test, environment variables, differences, databases, whatnot. In this particular case, I just chucked them in a project.clojure, but you can use Puppet and whatnot to populate them automatically, to decode them, uncode them when you need them. And the most important part is aliases. Aliases is like your tasks in Ant, where you provide how to run specific things locally, specific to a project. So this particular project is a web app that has 3 endpoints, 1 post and 2 gets. It has a database connection to the PostgreSQL, and it can read, write information in it. So to begin with, let's start with the model. Now, model is not like your entity in Java class. It's more of a connector, the repository to talk to the database. The closest alternative, or the closest thing I could find was, it's like Active Record in Rails, which does the database management as well as data management. And I know you're not the Rails crowd, but it's more the closest thing that I could find. So these 15 lines of code is all you need to configure your PostgreSQL database, to create 2 selects. In this particular case, I used just SQL, but you can use the libraries to convert them if you wish to, or use the maps and convert them SQL and vice versa, and to write into your database. Now, that's 15 lines of code. I had a conversation about it with my husband, who is a big Java 8 fan, and he's like, you can do this just as easily in Java 8. And I said, sure, but can you configure it in 1 line of code? He couldn't say yes. Again, it's not about comparing the languages. I just want to show you about understanding how it works right now. I just want to show you the power of this language and just how much you can achieve in just little code. This is all testable. And because it's Clojure, you can replace any function call. And in this particular case, the database configuration is like a function call. Actually, it's a data structure that's referred, but similar. You can replace all of them at any point of time. In this particular case, that's more of an integration test. So I'm replacing my development database with the test one and just talking to the test one. And you can write the test, and that's similar. I think that's actually one of those where you got the slide from. Yeah. Now it looks terse. It looks dense. It looks like lots of brackets. But you get used to this. It's more to begin with because you're not familiar with the language. It gets like, whoa, what's happening? Now let me move on to our handler itself. So the stuff that does the routing. In this particular case, the main things here are we have our item routes, which is the items endpoint. We have the post to items, get to items, and get to items with item ID. In the database, we're storing item name and item quantity, and there will be ID automatically generated and created at automatically generated. Another important part is you kind of start seeing here is app routes. App routes is where you define all of your routes as well as the error handling. In this particular case, I have route not found handling. And the coolest part is the web application configuration, where you specify your app stuff and glue it all together for Clojure to pass in and just deal with it in the back end. So that's in your app variable. And in this particular case, can you see at the back? Cool. And in this particular case, you have your app routes that refer to your routes. Then you wrap defaults around your app routes. And now it looks weird because there is a weird brackety thingy. I'm not going to go into syntax. If you want to talk to me, I can explain what it does. It does wrap JSON body, so it automatically detects whether you supply the content type of application JSON and converts it to idiomatic Clojure map. Wrap JSON response, it does exactly the same thing, but on the data out of your application. And wrap exception, that's just an example that I wrote my own handler for the errors, which just returns 500 with a message of an exception. That's, by the way, is Java. And again, that's all testable. All of the functions are replaceable, which means I can, because function is delivering val value and one value only, whenever I'm testing it, I can just replace it with a value, with a different value that I'm expecting it to return. And that's what I'm doing here. And that just tests all of our gets, posts, and whatnot. So does it run? That's the most important part. And I can assure you that it does. I'm starting it via line ring server headless. So what does it do is server headless is just, you can start your ring application with popping up in your default browser, the main page, the default index page. Well, I didn't want to do that because it's a back-end web app, and there are better ways to achieve that, but I just couldn't be bothered. I threw it together really quickly. So it's running on the port 3000. We can get our items that currently exist, and I'm piping it into JQ, JSON parser. And here we're returning all of our items that are currently stored in the database. You can get an item by one ID, so that should return just one item, and it does. And you can post to our application to save items. And there's created, 201, and trust me, it's added to the database because that's how all of the little things populated in the items through our test runs. So that's about it for me. The one thing that I want to tell you at the end is, so we have, about 50 lines of code in our handler, about 15 lines of code in our modeling and database manipulation. So I have a web app in 65 lines of code. So I know lines of code is not a definition, but I find it's cool. Anyway, so let me pass on to Andy. That's about it for web apps. If you have any questions to either of us, both of us are familiar with writing those things. And I'm going to pass on to Andy to conclude.
Alrighty. Okay, so a couple of things before I get to my closing statements, at the risk of sounding like a prosecuting lawyer. Some limitations. We did say at the start I was going to talk about some things which I found and still do find to some degree to be painful, coming from having spent a lot of time writing Java code. And this is not an exhaustive list, but these are probably the main four things that came to our mind. Relatively speaking, Clojure is hard to refactor. It's a dynamically typed language, which makes it difficult for IDE and refactoring tool authors to be able to get that same level of power as you get with something like IntelliJ and a statically typed language like Java. Being able to make those wide-ranging changes in function signatures, renaming, moving of things between packages, which is very, very easy in Java with one of those tools, you just don't have that same power and that same level of support with Clojure. Yeah. On the other hand of that, on the other side of that, I think you don't need to do it as much because the code you write, as Olga was showing you, tends to be less. So that notion of getting all of that code into your own kind of mental model to understand the application is, there's much lower tax on being able to do that. But there's not the support there that there is for a statically typed language. I'm not saying it's impossible because Smalltalk does that quite well and has done for decades and decades and decades. And Smalltalk is another dynamically typed language. So it is possible to build that functionality into refactoring tools. It's just not there yet for Clojure. Brackets can't do much about. I'm sorry, that's S expressions, that's all lists have those things. So, but they are painful. They are painful to the eye when you first start reading this sort of code. It does take a while for your brain to be able to scan and parse Lisp-based code if you're used to that kind of top to bottom scanning that you do a lot of when you're reading imperative code. Some people tend to, and I don't think this is a good idea, but they tend to use their IDE configuration, so they make the bracket colour almost exactly the same colour as their background. So the brackets just kind of like bleed into nothing. Probably a more sensible idea is to use a capability which is built into most editors, which is called rainbow parentheses, where it'll colour code with different colours, matching sets of opening and closing brackets. So it's much easier to see that this close matches that opening. Okay. It's not common. Okay, so Clojure as an implementation language is not common. It's certainly not common in Australia relative to Java. It's not common in the rest of the world relative to Java either. Like we know of IOOF, we know of REA that do it in Melbourne. There's probably lots of other places as well. Bureau of Meteorology, I think, is another place. Atlassian in Sydney, reasonably kind of strong Clojure people, at least they are since they employed an ex-thought worker who's a big Clojure person. Other places, Puppet Labs and Netflix and various other places as well. But from a talent pool point of view, if you're an employer, or from a getting a job point of view, if you're a potential employee, there's not as much choice as there is in the Java world. And that's a reality and probably will continue to be a reality, I think, for a long time yet. And finally, and this seems to be like a really petty thing to pick on, but the bloody stack traces in Clojure are appalling. If you don't like Java stack traces as they are, then you're absolutely going to hate Clojure stack traces, because not only do you get your typical Java stack trace for as many levels as it needs to be, you get at least an equivalently sized Clojure stack trace dropped on top of that as the program kind of drops out of the Clojure core libraries and starts to interop with Java. Okay, really, really painful. Okay, so they're like a good set of limitations. I mean, there's a learning curve, but there's a learning curve of anything you do new. So I don't feel, it doesn't seem right to put up there as a limitation. Doesn't matter what language. What's left? A bunch of things I haven't told you about, and I wanted to present some of these because we've spoken quite a lot about the differences between OO imperative style of development and declarative functional styles, but there are a lot of elements and a lot of things inside Clojure which might make you see that it's not that dissimilar to Java after all. Okay. There's a macroing system, okay, the ability to be able to extend the language using macros, which is certainly not in Java, not yet as far as I know. Java 9, I don't know, maybe, maybe not. But there are things called multi-methods which give you some sort of runtime polymorphism capability, dynamic dispatch. There are records for structured data. By default, all Clojure collections are heterogeneous, but if you want to have homogeneous collections where you've got the same type of thing in each element, then you can use records to give you that structured data notion. There are protocols which give you a lot of the same capabilities as interfaces in Java. If you need to do mutation explicitly, you've got three options. You can create variables using the def function call, you can create references, and you can create atoms. They're all ways of creating data which actually can be mutated. There are safer ways and less safe ways of doing that, but there are options there. Okay. Clojure implements software transactional memory through the doSync function call. If you know what that is, that will make sense. If you don't, we don't have time to talk about it here. It also does lazy evaluation. Okay, so the range function call will generate a collection of an infinite number, okay, 0 to infinity. How do I know it's infinite? Well, obviously I haven't counted them, but I believe the implementers when they tell me it's an infinite range. Which obviously if you call that in a language which is going to eagerly evaluate that, your program is never going to return to you because infinity is quite a long time. Clojure, because it's lazily evaluated and will lazily evaluate expressions like that, allows you to call that, it will return straight away, and it's only until you start to access that collection that it's going to start to generate those numbers. So if you want to generate an infinite list and only take 10 of those for some reason, you can wrap that range call in a take 10 function call, and that will return lickety-split. Okay. If you decide to write code that really, really wants to access every single element in an infinite list, yes, your program's going to go away and you'll never come back again, but it's generally not what sane developers tend to do, I find. If you're an Akka fan or an Erlang or Elixir fan and you like that actor model of inter-process communication, Clojure gives you something like that using agents. Okay, I say like that because it's not exactly the same. Again, scratch the surface and there are quite a few differences. And secondarily, I've spent no time with the agent stuff at all, so I can't speak with really any authority about it. But it's there. Bunch of other things as well, but this seemed like a nice kind of grab bag of extra bits and pieces to at least inform you about that they are there in the language without going into any detail. All right, back to our original premise. If all you have is a hammer, every job you kind of look at, you treat as though it's a nail. Our suggestion to you, if you do predominantly work in one paradigm and one set of languages is, and especially if you're a professional developer, I think we have an obligation to be able to kind of equip yourself with more tools. I'm not saying that functional programming or Clojure in particular is the best way to solve every single problem, but if it is at least another toolkit, another lens that you can look at your work through, it gives you a really interesting way of conceptualizing these things. Especially as we see that more and more attributes that are normally associated with functional programming are creeping into non-functional languages. Lambdas in Java 8 being one of those examples. And again, if you are the sort of person who takes the Pragmatic Programmer book at its word and you do like to learn a new language each year, and if you don't have any other functional languages under your belt, and if you are a JVM person, and I assume your presence here tonight means you probably are, Clojure is not a bad choice. I can talk later why I think Scala probably is a bad choice for that particular thing. Okay, bunch of resources. If you want to test yourself as to how good your Clojure code is, and more importantly, compare it to people who are very good at it, For Clojure is a nice online exercise tool to be able to do that. If nothing else, it will depress you with how little code it takes to solve things that you might write 5 lines to do. Clojure docs, the name says it all. Clojure cheat sheet, again, I think fairly self-explanatory. And finally, the Clojure toolbox, which is a curated set of libraries to kind of help you make probably not quite best practice choices for some of the things you want to do, but at least choose frameworks and libraries that are recommended by people who know that sort of stuff. All right, Olga and I thank you for your time. We'd like to spend a couple of minutes or so answering any questions if there are any. We'll see if we have to balance the mic while we're doing that. Okay. Okay. Yeah, sorry.
Yeah, so you mentioned that you could sort of swap out the return value of a function with a natural value. So does that mean that essentially you have your own internal Mockito in Clojure?
Well,
In a way, sort of?
sort of yes and no, because it's more about the understanding the paradigm rather than understanding the specific library. The paradigm is the fact that they are referentially transparent. You can replace at any time the function call with the value. You don't care about how it's mocked. You don't care about how it achieves the result. You don't care about what's happening in the background, whether it saves it somewhere, whether it does something. Just really care about that this function returns this value. And that's kind of the premises of the entire thing. So the paradigm helps to mock the responses and to help to test you.
Yeah, not having state to worry about, not having to worry about setting up an object in the right state to be able to mock it or stub it, makes that sort of stuff very, very, very easy. I think, Andrew, are you still? Okay. Yes.
How do you decide when to break everything up into files, or is it always just one file?
So the question was, in case the mic doesn't get it, how do you decide how to decompose Clojure code?
Do you want to go?
Yeah, look, I think it's not that different than how you decide to break up classes in Java. I mean, you have some notion, some mental model of what are the primary concepts that you're dealing with. Now, without that burden or otherwise of having to worry about state, it's not classes, it's more concepts. So it's more, are there a natural logical collection of functions you're going to be transforming the same type of data or transforming the data the same way? That's usually a good boundary to do it.
Corresponding to one business case or?
Yeah. Yep. And again, it's a bit of an arbitrary thing. and you can kind of play around with it fairly easily as well to find out when you've got the right sort of boundaries there. But it's not something. If it's seeming conceptually like you wouldn't know how to do it, I think once you get into it, it's a fairly straightforward activity. Like I remember the growing pains that I went through as a very, very new Clojure developer, and that wasn't one of them. Yeah. Yes, Andrew.
In your presentation, you described that interoperability between Clojure and Java, including like the dot notations and MelbJVM. And in Olga's example, I saw there are a number of times where you have to dig into Java to get functionality required. Do you find that obfuscates the code a little more than, say, if you were programming in this Haskell? Or do you find it not to get away too much?
Does the need to interop from Clojure to Java
Get
in the way of reading the code or writing the code?
I didn't find it personally. It's more about whether you can, it's more about picking the tool that you want to use to achieve a specific result. If you cannot do something in Clojure, you have access to Java. And if you cannot do something in Java, you can access to Clojure, but it's not as well, not as easily. It's more about changing your mindset and picking the tool that you need. I personally didn't find it that big of a deal.
Yeah, and certainly it does make visually parsing the code a little bit more complex because there's another pattern your brain has to start to recognise. Like it's a deviation away from that standard S expression sort of form. But I mean, I could probably count on maybe two hands the number of times I've needed to go to different bits of Java with all the Clojure I've written. Like most of it has been, and again, my experience has been writing small, fine-grained web servicey sort of stuff with database connection, kind of fairly typical sort of code. So yeah, we haven't found that it tends to get in the way. Yeah.
Yep. Yep.
I guess I have two questions in the context of very large code base, to be honest, not like a REST API.
Yep.
When you have hundreds and thousands of lines of code, how does the Clojure help you to do the team coordination, like interfaces in Java, etc.? So how it works out in the team coordination to share the code and build together? And the second one is more practical question. What's the time from writing code to execution, like building the build cycle? Because sometimes you just write one single code, but to run it takes 20 minutes. It's like it becomes a pain when you're dealing with large code bases. So how does Clojure help in that kind of situation?
Okay. All right, so the first question was, sorry, let me deal with the last question first. That way, it'll give me time to remember what it was. What's your workflow? Typically, I think is what you're asking. So one of the things that we touched on very briefly is the Clojure REPL. Okay, and if anyone here has used most other dynamic languages, Ruby being the classic example, a REPL is a fairly common thing. So it's an interactive shell where you can evaluate Clojure code. And I didn't know this, it's coming in Java 9. JShell apparently is a Java REPL. It's coming out. That is a core part of the workflow of every highly productive dynamic developer that I know. They test a lot of things very quickly, interactively in their shell, in their REPL, and once and test it manually and test it in an automatic fashion. Once they're happy with it, that's when they tend to transfer it back into their primary IDE to kind of form part of the code base. So that's very much a key part of working in that style of language, be it Clojure or Ruby or Groovy or any one of those sorts of things. And what was the first question again?
How do you do it?
How do you coordinate between different people?
Okay.
Like, do you use code? Do you publish interfaces? Do you publish function names? Or what's the documentation? So in a team environment, when you split the work between people, how does it work?
Actually, that's a really good question because I was working at IOOF in a relatively large code base, and the way that we did it is you fine grain. So you're trying all of the reusable function you put in the specific namespaces that correspond to what they're trying to achieve, and then you just call those functions again. Because you don't have the state, the problem doesn't arise that for example, somebody updated this particular object at this time and then the state changed and then all of a sudden the mess appears. It's more the fact that you just focus and write the test around and this function needs to return this value and that's all you care about, and then everybody can use this function if they want to. And then you fine grain it to get all of this reusable code and combine it together into big S expressions sometimes, but you usually split it into smaller functions. Also, how do you split it between the teams? Well, I would say the same way as in Java applications, and if you're working with, like, you have your Git to do the repo management, and then you do your merges or whatnot, or rebases if you need to. And it's exactly the same process. I haven't found any big differences. Have you?
No, and I think you treat it like if being able to scale up to support a large development team is a non-functional requirement, as it often is, that informs the way that you break up the code. Kind of coming back to your question originally, sir, which is you start to think a bit more around, look, where are the logical seams in this application? Where are we likely to have different people working on it at different times? And using that as a criteria for how you actually structure the code. And there's nothing to stop you multiple people working on the same source file in Clojure, as there is nothing to stop you in any other language, apart from potentially how painful your merges are. But you can certainly structure the code so that that is less likely to happen.
Honestly, I just saw functions and nothing. Is there any design patterns used? Do you need them at all?
Are there any design patterns used? Generally not from like a gang of four type notation, because gang of four is, they are object-oriented design patterns. There are idioms, like there are idiomatic things which you tend to see again and again, but they're not really expressed as design patterns. Olga did briefly go over an example of a macro called thread first, which was the hyphen and then the greater than sign after it, which is codifying one of those common ways of doing this common pattern of things. But there's not that large structural pattern sort of stuff like you get from that you get out of Gang of Four book. Yeah. I'm not sure if there's even an equivalent from a functional point of view. There possibly is. Yeah.
You mentioned in one of your limitations that you get a stack trace of Java and Clojure on top. That kind of implies at runtime that Clojure is running on top of all this Java stuff as well.
Yeah.
Are there any performance sort of impacts to that? Or is it...
Again, I personally haven't noticed anything in the applications that we were working. One thing that I gotta say, don't use Clojure to do Android development. It's the worst idea in the universe. It takes like 20 seconds to start an app. It's like, no. That's only for the backend or the services. But apart from this, it's pretty, I haven't noticed any delays that would be outrageous or comparative to, I haven't noticed any delays. I cannot say yet. What do you think?
Yeah, I suppose the two things that come to mind are the mismatch between dynamic typing and static typing, and the fact that I said right at the start, Clojure does use runtime reflection to be able to map those. You can turn on a compiler flag that will print out a warning every time it's doing reflection, and you can add type hints into all the Clojure code to say, this thing that you may not know about is actually a float, or this is actually a string, and that will prevent the need for it to do reflection, so that will give you a performance improvement. It's one of those optimizations that you wait until you have the problem before you actually do it. I think the other one is the startup time of the JVM initially, and because the Clojure core library, like I say, is like 2,000 odd classes, is nowhere near as modular as it could be. Like you do get the kitchen, not in a Spring MVC kitchen sink neck of the woods, but you do get a lot of stuff coming in. That core library could certainly be more modular, and it could be far easier to incrementally load that sort of stuff, because there is a startup tax on the JVM as it bootstraps itself into that Clojure library. And again, I don't work on a lot of stuff which is bound performance-wise that way. It's almost always at the I/O level, the database, the network. That's where the big performance problems are. It's not the execution of the code.
In terms of real world use or deployment, you might not be able to answer this, but where in the stack is it actually deployed? Like you said, Netflix, for example, are they building their whole web application service using Clojure, or is it some small component of it, or sort of where specifically is this being used in the real world?
So I know, I'm not going to use a Netflix example because I don't know. I think as a general statement, it's bits and pieces. I think because these, especially that type of companies over Netflix and the Googles and the Facebooks, they have a very polyglot type of development environment. They use lots of different languages for different reasons, and their architecture supports that. I can speak to what Atlassian use it for. They use it for a real-time chat application, which runs as part of their toolkit. But beyond that, I don't know of any organisation that is top to bottom, inside out Clojure, which is not to say there aren't any, but I just don't know of any.
Do you know what then drives them to say, okay, this component, we're going to use Clojure for that, rather than whatever they're using for the Rails or whatever? Do you know why?
In the majority of cases, you would use functional programming languages to do some sort of data analysis or manipulation, because they do this in a very idiomatic and very clean way. So if you do a lot of that, that would be the best choice, because you don't need to write a whole lot of boilerplate code to perform all of these things. Plus, they are performance optimized to deal with this data. That's what probably one of the main choices that I would choose, to use functional approach over the object-oriented programming approach. As well as, again, I showed you, you can write a web app in it. You can choose Clojure if you wish to, and you don't have to start with writing your entire ecosystem in one language. You can start doing bits and pieces here and there to sort of play with it.
So the sample code you showed, so had the database queries in line.
Yep.
So is that the preferred way to go in Clojure? How about database connection management and all that?
Well, in this particular case, we're using the JDBC Clojure wrapper around JDBC connector. So it's essentially the same approach, same plain old Java configuration. It's just wrapped in Clojure. Yeah. I don't know whether it answers the question, but yeah.
So I mean, just as a bit of a counterpoint to that, Cognitect, who are probably the main international organisation behind Clojure, have written a database called Datomic, written in Clojure, and it is an immutable database. In other words, there are no changes to existing data that's there. Every update you make is a new instance of that row. Like, it's very much an event sourcing approach to doing data. So I think again, it's up to the requirements that you're working within as to how you actually connect to your data store and how you actually interact with it. There are not ORMs, because O stands for object, but there are relational mappers in the Clojure world as well. And one that I'm thinking of is called OM, but I don't know very much about it.
Just one quick question. Build times compared to Scala?
Kind of compile times? Sorry, pass, don't know.
Don't know.
Yep.
Yeah, obviously your feelings towards Scala kind of hinted at here, so I'm presuming that they're a little bit better.
Look, I mean, just quickly, I mean, my slightly veiled reference to Scala before is not so much about the language itself. It's just, I think if you're going to pick up a functional language as the first functional language, don't make it Scala, because Scala is some Frankenstein bastard child of Java and functional programming. It's like going back to my tool analogy, it's like having a screwdriver which has a hammer at the other end of it. So you're kind of using this thing, oh, it's too hard to screw it in. Hey, I've got a hammer there, whack, 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 whack. It's too easy to revert back to the way you're used to writing code in a very imperative, object-oriented fashion. Like, I think Scala, in the end, if there was a battle between JVM-based functional languages, I think Scala's going to win, to be perfectly honest, but I don't think it's a right choice for your first functional language. I think you've got to dive all the way in, really immerse yourself in the paradigm before you have the ability to come back out again and work out how it interacts with a imperative language. Yep.
Any other questions? All good. All right, big round of applause. Thank you.
Thank you.